So if we do the same thing for the lower rectangle, we find the a sub L is again the width multiplied by f of, now this time we're using x sub 0 or x naught because we're using the left hand side, the value of x on the left of the rectangular strip. So the upper left corner is touching the curve. And then we do w f of x sub 1, w f of x sub 2, etc., etc. And so we end up getting this neat little thing here. So when we want to kind of find the difference between the two areas, we want to see, well, what does this level off to be? So we want to find the difference between these. So when we find the difference of a sub u minus a sub L, well, we see we've got w multiplied by f of x1, and here's w multiplied by f of x1. So that minus that cancel. Then we get w times f of x2, that cancels with that. W of f of x3 cancels with this next one. And then we continue down the line here. We've got, and I'll go to the end here so we can see this. W multiplied by f x n minus 1 cancels with this, x minus 1, n minus 1. F of x n minus 2 cancels with this, and there will be another one here, f of x n minus 3 cancels with this one. So what we're actually ended up with here is just w multiplied by f of x sub n and w multiplied by f of x naught. So the area, the upper area minus the lower area, ends up being w times f of x sub n minus w times f of x naught. We can factor the w out, so we get w, sorry about that, I missed that, f of xn minus f of x naught. And well, x naught, x naught is this value of a right here, and x sub n is the value of b. And we know that w from before, w was written as b minus a divided by n, which can be rewritten as 1 over n multiplied by b minus a. So the area, the difference in the areas between the upper and lower rectangles, is nothing more than 1 over n multiplied by b minus a, which is, that's w, multiplied by f of b minus f of a. Okay, so things are simplifying here quite nicely. And now we've got this. As we continue to increase the number of subintervals, the rectangular strips, n is going to approach infinity. So we can see that the limit, as n approaches infinity, of 1 over n, that's going to equal 0. Therefore, that means that the limit, as n approaches infinity, of the area of the upper rectangles minus the area of the lower rectangles, that's going to equal 0. So the difference between the two is going to be 0 as we increase the number of subintervals. Which means that we're actually, that if a sub u minus a sub L equals 0, then that means that the limit as n approaches infinity of a sub u is equal to the limit as n approaches infinity of A sub L. So as the iterations increase to infinity, the limit of the upper area is equal to the limit of the lower area, which means that we can say that the lower area from before less than the actual area under the curve less than the upper area. Well, when all of this occurs, we're going to see that the limit as n approaches infinity of A sub L is less than, or sorry, is now equal to, sorry about this, because if these two are equal, and those are the boundaries, that's going to be equal to the limit as n approaches infinity of the upper areas. And of course, because the lower area is less than the actual area, which is less than the upper area, if these two are equal to each other, then that means that they have to equal the actual area under the curve. So this is true when the function is increasing, and when, or sorry, it's a positive function when we've got a less than x less than b. Okay, and so this is now called the definite integral. So the definite integral of f of x, when we go from a to b, is written as the area is the definite integral from a to b of f of x dx. So that's going to be the notation for us for this. Okay? And that is going to equal the area under the curve of f of x between a and b. So the difference, the area under the curve and the x-axis from along the interval from a to b. Okay, so that's what all of this means. So we're going to take a look at a few examples tomorrow, and then after we take a look at the examples, which will just kind of highlight this one more time, then I'd like you to take a look at questions on page 444, numbers 1, 2, and 4, and on page 446 to 447, numbers 1 to 3. Okay, so please look at those, and I'd also like you to look at any examples that are in the textbook. Click on the self-tutor and listen to her explain the solutions to those examples. Alright, so thanks for watching, and we'll see you in class.